In Activity 2, Parachutes, students use parachutes to demonstrate how air resistance can counteract the force of gravity by slowing the rate at which an object falls. You will need the following materials from the kit: Activity Sheet 2, Parts A and B, rubber bands, wooden clothespins, dry cleaning plastic bags, kite string, and transparent tape. You will also need to provide sheets of plain paper, metric rulers, scissors, and pictures of parachutes and skydivers. To prepare for the activity, make a copy of Activity Sheet 2, Parts A and B for each student. Cut open the plastic bags, lay them flat, and cut each bag in half. Ask students to bring pictures of parachutes and skydivers to class. Each team of 2 will need 2 sheets of paper, a ruler, a pair of scissors, 2 clothespins, a rubber band, and 1/2 of a plastic bag. Teams will share the rolls of string and tape. You will need 2 sheets of plain paper for a demonstration. To begin the activity, crumple a sheet of paper. Hold it up, then let it drop, and ask students, "Why did the paper fall?" Some students may be familiar with the concept of gravity. Explain that gravity is the force that pulls objects, like the paper, downward toward Earth. Distribute a copy of Activity Sheet 2, Part A, to each student and tell them to answer the first question. Next, hold up a flat sheet of paper and a crumpled sheet of paper. Ask students, if these 2 pieces of paper are dropped from the same height at the same time, which do you think will hit the floor first? Have students record their ideas. Divide the class into teams of 2 and distribute 2 sheets of paper to each team. Instruct students to test their predictions. They will see that the crumpled piece should hit the floor first. Then ask, why did one piece of paper fall faster than the other? Students may suspect that the shape of the paper had something to do with it. Remind students that air is made up of molecules. Explain that when an object falls, it knocks into the molecules. The resistance of the air molecules being pushed aside is called air resistance. The more molecules an object encounters, the greater the air resistance, thus the slower it falls. Go on to explain that the surface area of an object is part of the object that is exposed to air. Lead students to conclude that because the flat piece of paper had greater surface area, it encountered more molecules of air, therefore more air resistance. Tell students to complete activity sheet questions. Next, pass around the pictures of parachutes that students have brought in. Ask, what is a parachute used for? Explain that a parachute is a large umbrella-shaped object that slows the speed of a person or object falling through the air. Then distribute the materials and instruct students to make 1 large and 2 small parachutes. Measure and cut out 3 squares from the plastic bag. 2 of the squares should measure 25 centimeters by 25 centimeters. The third should measure 40 centimeters by 40 centimeters. Cut 12 lengths of string, each 30 centimeters long. Tape the end of 1 string to each corner of the plastic squares. Gather the 4 strings and tie the ends together in a knot centered under the plastic square. Attach a clothespin to the string knot of one of the small parachutes. Hold up one of the models and point to the plastic square. Identify this part of the parachute as the canopy and have students label the drawings on their activity sheet. Ask, what do you think the canopy is for? Students should guess that the canopy provides a lot of air resistance. Next, identify the strings as the suspension lines which connect the canopy to the harness. The harness is attached to the skydiver or cargo. Have students add these labels to their activity sheet. Next, distribute Activity Sheet 2, Part B. Hold up a clothespin and a clothespin attached to a parachute and ask, if I dropped these 2 clothespins from the same height at the same time, which do you think would fall more slowly to the ground? Allow students to take turns dropping the clothespins from the same height, at the same time, and observing how they fall. After students have completed their drop tests, ask, which clothespin fell more slowly? They will see that the clothespin with a parachute attached fell more slowly. Then, have students wrap a rubber band around the canopy of the other small parachute and attach a clothespin to the knot in the string. Have them predict which will fall to the ground more slowly, and then repeat the test. Finally, have students remove the clothespin from the small parachute with the rubber band around its canopy and attach it to the large parachute. Repeat the test again, this time comparing the falling rate of the clothespin with the small parachute to the falling rate of the clothespin with the large parachute. When all teams have finished, ask students, of all the test drops, which clothespin fell fastest to the ground? Which clothespin fell slowest? Students should say that the clothespin without a parachute fell fastest, and the clothespin with the large parachute fell slowest. Ask students, what conclusions can you draw about the size of the canopy on a parachute and how slowly the attached clothespin falls? Students should conclude that the larger the canopy, the greater the air resistance. The greater the air resistance, the slower the parachute and attached clothespin fall. To conclude the activity, collect the materials and return them to the kit. Discard the remains of the plastic bags. You can discard the parachutes, suspend them from the ceiling, or let students keep them. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.